At the edge of everything, there is nothing. You may have seen pictures of deep space. They look like black cloth with some shiny spots. These are stars, and even though they look like they're close together, they're very far away. Some are thousands of light years from us. It can take thousands of years for their light to reach Earth. We see them as they were in the past. This means we can only see things that are relatively close to us. There are also limits to what we can see with our eyes and with current technology. But soon, if all goes well, we will be able to see farther than ever before. We'll be able to peer back almost to the beginning of time, to see the first galaxies and maybe find other life out there in the universe. This will be possible thanks to the James Webb Space Telescope. It is much more powerful than the Hubble Space Telescope. It will be able to detect the heat signature of a bumblebee at the distance of the Moon, so it could easily spot a planet outside of our solar system and study its atmosphere. But the James Webb Space Telescope won't be orbiting Earth. It will orbit the Sun, but farther away, at a special spot called Lagrange Point 2. This is about 4 times farther away from Earth than the Moon is. You might wonder why they chose such a faraway spot. It's because the James Webb Space Telescope needs to be really cold to do its job. The telescope will constantly be bombarded by light from the Sun, Earth and Moon, so being at Lagrange Point 2 will keep it cool. It's also important that the telescope doesn't pick up too much light from Earth. Scientists wanted to detect the faint heat signatures of faraway planets. To get it so far away, the James Webb Space Telescope had to be folded up like origami. Its mirror is 6.5 meters wide, but to fit inside the rocket, it had to be folded up into a hexagon shape with each side only 2.4 meters long. The whole telescope was also covered with a silver sunshade the size of a tennis court. All of this made the James Webb Space Telescope the largest telescope ever placed in space. When it arrived at Lagrange Point 2, it unfolded like a piece of origami coming to life. Once fully deployed, the silver sunshade acts as a giant umbrella, blocking the light from the Sun, Earth and Moon. This keeps the telescope in the shadows, allowing it to cool down to about 233 degrees Celsius. At this temperature, the telescope can do its job. The main goal of the James Webb Space Telescope is to observe things that are very far away, like galaxies and stars that are billions of light years from Earth. Light takes a long time to travel. It takes 8 minutes for light from the Sun to reach Earth. And since the Sun is one of the closest stars to Earth, most of the stars we see are much farther away. Light from the star Sirius takes 8.6 years to reach us, so it would take 8.6 years for us to find out if Sirius went out last night. The James Webb Space Telescope will be able to observe things that are very far away, because it will detect heat instead of just light. Heat travels differently through space. It moves through a process called radiation. The hotter something is, the more it radiates. So an object that is very hot will radiate a lot of heat. Also, the hotter the object, the shorter the wavelength of its heat radiation. Conversely, the colder the object, the longer the wavelength. This means that an object that is very cold will not radiate much heat. But James Webb will be able to detect the heat waves, because they will be stretched when they pass through space. This is known as the Doppler effect. As the heat waves travel through space, they'll be stretched out. This makes the waves longer and the frequency lower. The James Webb Space Telescope will have special sensors that will detect these low-frequency heat waves, so it will be able to see things that are very far away. James Webb will also be able to see things that are very small. For example, it'll be able to see comets and asteroids. These are rocky bodies that are leftovers from the formation of the solar system. They're very small compared to the Sun, Earth and other planets. But James Webb will be able to detect their heat and track their movement. The James Webb Space Telescope will also be used to study exoplanets. These are planets that orbit other stars. There are billions of exoplanets out there, but we don't know much about them because they're so far away. James Webb will be able to detect their heat and study their atmospheres. This will help us learn more about planets outside of our solar system. The James Webb Space Telescope will also be used to study the formation of planetimals. Planetimals are small rocky bodies that orbit the Sun, kind of like asteroids, but smaller. They range in size from a few feet to several miles across. Planetimals are thought to be the building blocks of planets. They're the leftovers from the formation of the solar system, so studying them can tell us how planets formed. One of the questions scientists have about planetimals is how they formed. There are two main theories. The first is called hierarchical accretion. This theory says that planetimals formed from large disks of gas and dust that surrounded the Sun. Over time, the particles in the disk collided and stuck together. They grew larger and larger until they formed planetimals. The second theory is called local cloud collapse. This theory says that planetimals formed when small clouds of gas and dust collapsed. Gravity caused the clouds to collapse and form planetimals. There is evidence to support both theories. Scientists have studied rocks brought back from asteroids. The rocks have different chemical compositions, which suggests that they came from different parts of the solar system. This could support the hierarchical accretion theory, since it would mean that planetesimals formed from material that was mixed together. Or it could support the local cloud collapse theory, since it would mean that planetesimals formed from material that was isolated. Scientists are hoping that the James Webb Space Telescope will shed light on this mystery. One of the things scientists hope to learn is whether planetimals formed quickly or slowly. If they formed quickly, then it would suggest that they formed through local cloud collapse. If they formed slowly, then it would suggest that they formed through hierarchical accretion. In addition, scientists want to know how planetimals moved around in the early solar system. Did they move around a lot, or did they stay in one place? If they moved around a lot, then it would suggest that they formed through hierarchical accretion. If they didn't move around much, then it would suggest that they formed through local cloud collapse. Researchers studying data from NASA's OSIRIS-REx mission have discovered some clues about how planetimals formed. The OSIRIS-REx spacecraft flew by an asteroid named Bennu in 2019 and collected samples of the asteroid's surface. The samples are being returned to Earth for study. The researchers focused on a particular type of rock called a meteorite. Meteorites are pieces of rock that come from space. They usually form when an asteroid is hit by a comet or another asteroid. When the asteroid is hit, pieces break off and fall to Earth. Scientists can study meteorites to learn about the conditions in space. The researchers found that the meteorite had a smooth surface. This was surprising because they expected it to have a rough surface. The fact that it has a smooth surface suggests that it formed at low speeds. If it had formed at high speeds, it would have been rough. This supports the idea that planetimals formed through local cloud collapse rather than hierarchical accretion. The James Webb Space Telescope will be launched in December 2021. It will take about 6 months to reach Lagrange Point 2. Once it arrives, it will begin its mission to explore the universe. Scientists are excited to see what James Webb will find. Maybe it will find evidence of life, or maybe it will solve the mystery of how planetimals formed. Only time will tell. But one thing is for sure, James Webb will change our understanding of the universe. It will allow us to see farther than we've ever seen before. It will allow us to study things that are very far away and very small. It will allow us to explore the mysteries of the universe, and it's all because of human curiosity. Humans have always been curious about the universe. We've always wanted to know what's out there. The James Webb Space Telescope is the latest step in our exploration of the universe. It's the next step in our quest to understand our place in the cosmos. And it's all because of human ingenuity. Humans have a remarkable ability to innovate and solve problems. We've come up with some amazing technologies that have changed the world. The James Webb Space Telescope is the latest example. It's a marvel of engineering and science. It's a testament to human ingenuity. If you enjoyed this video, please leave a like. It helps us produce more videos like this. Thank you for watching. We'll see you next time.